All right, thank you, Michelle. Um, all right, well, appreciate you guys bearing with us through the IT portion of this meeting, get through the technical concerns. These are always fun, even though we've been doing these virtual meetings for almost 2 years now. We still sometimes run into challenges. So just real quickly, Michelle did a nice job introducing me. Today we're going to talk about building a better sediment basin. It's a slightly different topic or title than what we had originally published, but we will be talking about how to use skimmers during construction and post-construction and to improve water quality. All right, well, first off, I should introduce Warren Fairclough. He is not here. He is taking a well-deserved, long overdue vacation to Europe that was put on hold ahead of during the pandemic. So I've just introduced him. He is the inventor of the sediment basin skimmer. And Warren was, for 18 years, he administered the Urban Erosion Control and Stormwater Program in Orange County, North Carolina. And it was in this capacity that he had the opportunity to develop the skimmer sediment basin. In 1996, Warren received an award from the International Erosion Control Association for Technical Presentation of the Year. And then in 2007, he received the IECA's Environmental Achievement Award. And here's a picture of Warren with one of those awards. So just a quick overview of what we're going to discuss today. And hopefully, I hope Michelle is going to manage the chat comment section of this. If not, if you guys aren't getting, we missed that, just pipe up through the presentation. You can take yourself off mute and ask a question if there's any thing that's not clear that I present. So just a quick overview. We're going to go over some stormwater rules and regs, particularly as it relates to the construction general permit. A brief history of sediment basins and skimmers, where these guys came from. I give you some key components for efficient sediment basins. Really how to select and specify skimmers, and share with you some design tools and resources. And then we're going to discuss an innovative technology for post-construction stormwater management. So I like this picture. It really just frames up our conversation today. It really, for me, defines the why we do this. I'm sure all of you are passionate about protecting our environment and our water quality. And, you know, at the end of the day, I just ask stuff, which side of this river would you rather be swimming in, drinking from, fishing in? This is downstream from a wildfire burn 4 years after the fire occurred. So I'd just like to point out, you know, water quality affects all of us. And sediment is the leading cause of water pollution. And of course, you guys know the U.S. has laws to protect water quality. Particularly the construction general permit as it applies to construction and development rules. And I'm going to get through, if you guys can stick with me for the next 3 or 4 slides, they're a little text heavy, but after that, we're going to mostly be pictures. So, you know, the erosion and sediment controls permittees are required to design, install, and maintain effective erosion controls and sediment controls to minimize discharge of pollutants. And, you know, at a minimum, we need to control stormwater volume and velocity, control stormwater discharges, including both peak flow rates and total stormwater volume, and minimize sediment discharges from our sites. And really, as it pertains to today's conversation, this rule right here regarding surface outlets in the construction general permit states that when discharging from basins and impoundments, permittees are required to utilize an outlet structure that withdraws water from near the surface. And I wish they hadn't put this unless infeasible there. We don't need to give contractors any wiggle room on this, but this is the rule that really defines how we use sediment basins here in the state. So the status quo in North Carolina is we use, well, traditionally these perforated risers have been utilized in order to in order to dewater the sediment basins. And as you can see, here's just a drawing, and it's basically a riser pipe with a bunch of holes drilled in it, wrap it with a little geotextile filter fabric, and then put a bunch of rocks around it. And it's very basic, but as you can see, we're still going to be draining this basin from near the bottom, and this is just really ineffective at controlling the filling and the draining of the basin. Here's some drawings of what that looked like, or some actual illustrations. You can see here's the riser pipe with that rock stone wrapped up around it. And you know, any filter that is doing its job is going to capture material. If you think about your lint filter on your dryer, you know, we need to change that, you know, usually after every dryer cycle or two, or else it clogs up and it just doesn't work. And same thing with these filters on these perforated risers. You know, once that you get a couple good rain events, you have all the sediment coming in there, it blinds over that filter fabric, and then how do we maintain those? And typically they're not maintained. So subsequent rain events, we're looking at overtopping the emergency spillway on our basins. So just for clarification for this talk, when we talk about sediment basins, we're typically talking about larger drainage areas greater than 5 acres. In some states, we're permitted to go up to 80 to 100 acres of drainage area. And these sediment basins are typically characterized by a permanent outlet structure, as you see down here in the left-hand corner. That permanent outlet structure like I said, this is typically what you'd see for a sediment basin compared to sediment traps. And you know, here's a sediment trap with the skimmer. The skimmer is attached to a 4-inch piece of PVC pipe that goes through an earthen dam with a spillway up here over the top. These are very, very common in North Carolina, particularly on DOT projects. You'll see a lot of these. They're for smaller drainage areas. Sediment basins are usually for areas of drainage areas of 5 acres or less. Is what we're looking at for these. And there's literally been thousands of these traps built around North Carolina, and they're very efficient and an economical way to control sediment where we have concentrated flow. So a little background on coming up with the skimmer concept. This is a typical basin, specifically a trap in what Warren calls the Stone Age. This was standard design and practice in the early 1980s. No one really, as he says, no one really knew what they were doing. It was just a bunch of opinions and some experience that people had. And it was allowed that the volume could be reduced if it was cleaned out more than once a year. And this was really a disaster. As you can see here, this basin is completely full of sediment, no remaining storage for the next storm. And you'll notice the large amounts of sediment over here outside the perimeter of our job site, you know, going down into the woods. And this is typical sediment loss. You can see from traps built this way, here's a hatchet, put it in here if we scale it to show you the amount of sediment coming off that site. Although this was common, it was clearly unacceptable, and basin design needed to be changed to improve performance. So when Warren was in Orange County, he took steps to change the way sediment basins were designed. One of the attempts to improve sediment basins was to size the basin for the entire drainage area, not just the disturbed area. And research stated a need for baffles to work properly. He had never, Warren will tell you, he had never seen a baffle or even a slide of it. As he likes to reference, this was before the internet, and so he couldn't Google what a baffle was, but he seemed to make sense that, you know, baffles should make the flow meander through the basin to increase the flow length and the time of travel and give more time for settling. These baffles seem to be doing that, but as we'll talk about later, you know, assume nothing here. And if you note you accumulated sediment behind the baffles, but also note that this debris line, this is actually after Hurricane Fran. And for anybody who was in North Carolina in the fall of '96 when Fran came in. It's my senior year in college. I remember, Raleigh flooded, and this basin, as you can see the debris line, it never filled up. And part of the reason was that stone, there's a lot of void space in that stone, and allowed the stormwater to go straight through that stone, and didn't encourage proper filling of the basin nor dewatering it. So it really could not control the filling or the draining of that basin. So nothing in design took that into consideration. There was no thought given to the flow through the voids and preparations and a riser that would control the filling and the draining and cause it to fill with that initial rainoff and create the conditions for settling. And again, this drains from the bottom, and you just ask yourself, does this make sense? And what Warren, when he looked at this, what he thought was needed was a floating surface drain to release the cleanest water over several days, and this would have caused the basin to fill with the initial runoff and then create conditions for gravity settling. So this is the first skimmer that Warren made. He convinced the developer to let him use his basin as a laboratory. He installed it, waited for it to rain to see what would happen. It's about as scientific as it got. He waited about 2 months for it to rain, but after that one storm, that first storm proved the concept that the basin filled with the initial runoff and then slowly dewatered over a period of time, and there's just a slight dusting of sediment downstream compared to the pictures that we saw on the previous slide of the sediment damage. So he knew he was on to something, and his idea was he wanted the skimmer to be so simple that any contractor could make one. He never imagined getting into the business of making skimmers. He had a good, comfortable job where, with the state where he could do interesting things like this. However, he found contractors cut corners making them, and they didn't work properly, and that discredited the concept. And then he also discovered that contractors typically wanted to just take something out of the box, install it, and get back on their equipment. So he found he had to get into the business of building skimmers, at least in a small way, to provide a quality skimmer. And the design had to be more complicated to solve various problems. And this design evolved to solve the problems that he encountered using the skimmers in actual conditions found on construction sites. And so I've showed you a series of his early designs here. And, Einstein's accredited with saying, make a thing as simple as possible, but no simpler. So Warren really kept that in mind when we came up with the final design for his skimmer, the one that we've used for almost, a little over 20 years now. And we like to say his original tagline was on the cutting edge of common sense. And so here's the skimmer. Just to kind of point out here, this bottom piece right down here is where we attach to the outlet structure. You have a flexible handling hose right here. It's a heavy duty reinforced hose right here. It connects to the barrel arm, which right here that will connect the flex hose up to the skimmer. Here, the C-shaped float is the float. We have these black pieces here are trash guards to keep floating debris from entering into our skimmer here. We have a screen over the top to keep smaller debris out. And then right here inside, this is our orifice, and there is a vent right here. And you'll notice the vent is below the orifice, and that's important because that's what allows for gravity flow, so we don't get into a situation where we have siphoning occurring. And here, once we open up this screen, you can see the orifice is right up here at the top. Each one of the skimmers, the orifice on each side of the skimmer, I'm sorry, let me back up. We make 8 different size skimmers, and the orifice on each size can be reduced to customize the flow rate. And you'll notice that the orifice is at the inlet where it has a constant head and is accessible for inspection and cleaning. let's see, and we sized this, the skimmer is sized, the skimmer and the orifice is sized for the basin's volume and the number of days to drain the basin. And there's a cutter included, and it only takes a couple minutes to cut a hole in the plug or plate and install it. So again, this was playing at the beginning. Again, this shows the screen, how you can open it up, change that orifice size plug, and again, the skimmer controls the filling and the draining of the basin. And so these skimmers can be used in sediment basins or in sediment traps like we see here. And this is where it's just showing the connection piece going into that PVC going through the earthen dam there. In the sediment basin where we're attaching it to a permanent outlet structure. There's an up close of that. You see a stub out from the metal riser, and it attaches to a threaded coupling and just does the end of the hose. We do have instructions for attaching it to a concrete riser. And we've even used these in tanks. These are some Baker tanks out in California at a landfill out there. Putting the skimmers in there, they're really using these almost as roll-off sediment traps. And one note, if you do ever plan to use these in a tank, we should talk first. These were shipped on site, and then the engineer asked, well, how am I going to get these in my 20-inch manhole? So we had to take a trip to California and cut these and to be able to get them inside the tanks and reassemble them. So as I mentioned earlier, baffles are a key component of efficient sediment basin. The skimmer is just one piece of it. And here you see some baffles that were installed. The basin really needs to be designed to handle the volume of the total drainage area, not just the disturbed area. And we want to make sure that clean off-site water is not running into this basin, or come up with strategies to divert it. So these baffles here are utilized. The baffles help utilize the entire surface area for settling. And these are some of the first attempts to use baffles, and they seem to work based on the sediment accumulation behind the baffles. However, the solid baffles are deceptive in that they would channelize flow, keeping the velocity up and that would keep the sediment suspended. And these faults were discovered during sediment basin research conducted at NC State University Soil Science Department. And here's this research, the initial research that was done. This red line showing just the free flow of the velocity coming into the basin. Part of the challenge when you're not using the baffles is that you tend to shortcut through the basin from the inlet straight to the outlet, leaving dead zones on the side of the basin, and the velocity stays up high. When we used, you can see here what they call sediment fence or silt fence, some of those initial ones, we're still keeping that velocity up pretty high in here, but when we use jute fence or it's a porous baffle, typically now we use a core baffle because it's better for an aquatic environment. But this green line, you can see, here's each one of the cells. So here's the first set of baffles, second set, third set, and you can see when we hit those baffles, we're really slowing that velocity down and increasing the time for settling. So when we talk about the core baffles, porous baffles, this is what we're referring to, and this is part of the design manual for North Carolina, is using core baffles. And some really interesting research done down at Auburn University. This is Dr. Jamie Schisler here. We added dye to this water, and it really just shows how using these porous baffles, how it takes the velocity out of the water flowing in, but it also spreads that laden water across the entire surface area and volume of the basin. So we're really making use out of that the hole down. You see when the dye hits here, it starts to slow down. And then in this picture here, you can see it completely spread across this cell before, and it's just starting to kind of creep in here. These porous baffles are a very important part of making an efficient sediment basin. So not only do we have 20 years experience making skimmers, they've also been thoroughly tested on construction site and research facilities. This is showing 8 of the skimmers we make in test basin out at North Carolina State University. You know, in a typical sediment basin with a conventional outlet, like we showed, there's perforated risers. They tend to capture less than 50% of sediment entering the basin. And the question was posed, well, what would a properly designed and constructed basin with a floating surface drain, what would be the efficiency of that? So Melanie McCaleb did some research, actually her master's thesis, on the effects of design changes on sediment retention basins. And here's a picture of Melanie out there. I like to throw these pictures in, really demonstrates her credibility and commitment to the science here. So as we see, the traditional trapping efficiencies of a standard 10-year trap was about 37%, depending on, there's a couple of different traps. This one's 37, this one's 46%, so below 50% trapping efficiency. When we move that standard trap up to the 25-year trap, obviously we're sizing these much larger, and that efficiency goes up considerably, almost doubles up here to 90% efficiencies. But the skimmer basin has the highest trapping efficiency of greater than 99%. But like everything, it needs to be maintained, and so after several months of not maintaining it, that efficiency drops. And so we'll talk a little bit about how these are to be maintained. But a quick picture of what that 99% capture basin design looks like. You see we have stabilized slopes with vegetation and matting around the sides of the basin. The slopes are 2 to 1 or less in steepness. You have an energy dissipator right here at the inlet to slow the velocity flowing into that basin. We're using the porous baffles here, and then using that skimmer surface drain to discharge water from the basin. And it was originally found in Melanie's research that the basin itself, the BMP that's supposed to help us reduce sediment discharge, was a major contributing factor because the slopes were too steep, they're sloughing off, and we're contributing greater than 50% of the sediment going into the basin was coming from the basin itself. So City of Charlotte does a really good job of publishing some guidelines and their land development standards. And as you see up here in this corner, we want a length to width ratio greater than 2 to 1 up to 6 to 1. So these basins are longer than they are wide, giving a longer time of travel. And when we see the minimum volume required, this is the volume at which we need to clean out the basin. At this point, we typically design these basins to have 3,600 cubic feet per acre of storage area. That will account for a 1-inch rain event. When that volume is reduced to 1,800 cubic feet or half of that, we need to get in and do some maintenance. It's really good if you're a designer to be able to put do your calculations here, and then we put in the size skimmer required. I put it right here in the plans, easy for the contractors to bid on and to install for the plan details. And it's important also to have a rock pile or something for these skimmers to settle down on so they don't settle down into the mud. That will allow for a small rain event to occur, and the water will, in small rain events, you won't be discharging that muddy water. As you can see here, that's that longer length to width ratio with a series of at least 3 porous baffles in there. A nice stabilized inlet there, so that inlet is not contributing to erosion within the basin. And here's a side view of the basin, again showing our our stabilized inlet here with the rock dissipators, a series of 3 baffles, our skimmer, and a nice little rock pile. And this is a really clever design detail to include in is a clean out stake. Because not many people could look at a basin and just be able to tell what 50% of the storage capacity is in that basin. But putting a clean out stake in at the volume at which the basin is half full is a great way to indicate to inspectors, to the contractors, to designers, when the basin's at 50% capacity and maintenance needs to be performed to restore the storage volume of the basin. Okay. And it should be noted that another problem that can be encountered is turbid outflow from the skimmer over several days, and obviously this can cause complaints from adjacent landowners. And there's a possible fix for this turbidity. It's worth pointing out that the skimmer by itself does not produce clean, clear outflows, particularly in clay soils. So we have some other tools at our disposal. In North Carolina, we are allowed to use flocculants. Particularly what we use here in the Southeast is polyacrylamide. It's a linear anionic polymer. It's very important that you use one off the DEQ's approved list. It has undergone toxicity testing. These are typically food grade polyacrylamides that have a half-life of 48 hours or less, so we're not concerned about bioaccumulation in the environment. But the way that these flocculants work is that they bind suspended sediment by attaching several soil particles to the exchange rates on these polymers. So it binds these, takes a bunch of small particles, binds them together in larger particles, and then those larger, now heavier aggregates then will settle out of suspension. So this is actually a fun little magic trick when we're in person. Love to do this at trade shows. It's pretty cool how this technology works. It's really best if you can use the polymers or the flocculants in a treatment train and in conjunction with a fibrous matted material or wattles. They just do a great job. It's something about the natural fibers tend to grab onto this flocculated soils and hold them very, very well. So on this, we would have put a powder polyacrylamide into this channel. It's important to introduce the flocculants up gradient from the sediment basin, so there's plenty of time for activation, for the mixing, the aggregation, and allow that chemistry to work to drop the suspended solids out of solution. And this was this again out at the research station out at NC State. You can see these core wattles here were impregnated with polyacrylamide, and it created damming behind each one, pooling behind each one of these flock logs. We took samples behind each one of those logs, and you can tell as we go down through the treatment train how the water gets clearer and clearer and clearer until we're finally discharging here at the end. And this is a stone ring dissipator at the outfall, entering into the basin, and you can see that stone on the bottom is stained with flocculated soil. But this is what we're looking for. We really want to capture that flocculated soil in the basin. So again, it's important to utilize these flocculants up gradient from the basin, so we can capture that flocculated soil in the basin. We don't want to be discharging that off-site. And this water it's really clear. There's a bad glare on this. It doesn't really highlight how clear this water is, but this is very clean water. So when we get this clean, clear water on the top, and we're skimming the skimmer skimming off the top, we're getting really good results coming out of these basins. So it's important to just highlight what the skimmer does not do. It does not make a hole in the ground in an efficient basin. Doesn't allow for reductions in basin size because of improved efficiencies, and will not overcome inefficiency caused by poor basin shape or design. And by itself, the skimmer does not produce clean, clear outflows, particularly in clay soils. What it does do is it regulates the filling and the draining of the basin. Utilizes the basin's volume and surface area, drains the basin from near the surface at a nearly uniform rate. It allows, and that reduces the velocity of that stormwater discharge. And it also allows for the varying of the drawdown time by changing the orifice. And all these are going to improve efficiency of the basin. And like anything, it is important to inspect and maintain these. So, you know, whatever triggers your inspections on your site, it's important to go over and look at that sediment basin and the skimmer, see how it is performing when we're out there doing our site walks. Nothing is truly maintenance free, and again, there's skimmers need to be inspected with regular site visits and maintained to continue to perform properly. So this is kind of a little bit of a bloopers reel. This was someone who built their own skimmer, and one of the prerequisites of a floating surface drain is that it floats, and clearly this one did not pass that test. You know, you want to look for kind of vandalism or damage to the skimmers. This one, well, there's just a lot going on in this picture. You know, the baffles should have been carried all the way over to the side here. Obviously, there's this thing is at capacity. It's not been maintained. Again, as we talked about, we should have had this should have been cleaned out when it was at 50% capacity. There's not a whole lot of vegetation up here or anything keeping all this from just ending up here. You can see our capacity is just really, this is just a poorly maintained site. This one was actually, you can see the skimmer's out of the water, so how was it draining? There was actually a poor connection to the, it was not, the connection from the flex hose to the outlet structure was not sealed, so it was draining from the bottom around the outlet. Obviously, this is not going to float. And I had a contractor, or actually an inspector in Ohio, that sent this one to me, and just thought it was kind of funny. I don't know if you can see the piece of rebar the contractor put here to keep the skimmer from floating up. He said it drained better when it didn't float on top. So, you know, and in North Carolina, we do deal with some ice. Typically, 2 or 3 inches of ice are not going to be a problem for the skimmer. Typically, what it would do here in this situation, the skimmer continued to drain and just deform the ice into a bowl. But in certain climates where the water is going to freeze, like in Minnesota, we just pull these out at the onset of winter before the water bodies freeze over. And clogging can be an issue, especially in the fall when we have leaves or after the site has been mulched with straw mulch and it rains. You know, the float does act as a guard for floating debris, but in this type of situation, all the skimmers come with a rope attached to them, and we just typically will tie this to a T-post on the bank and just give this a couple little tugs and it'll swish all this free. If it doesn't, we showed you earlier pictures how you can just pull this over to the side and clean it out. Oops. And here's what happens. You know, you just need one seed caught in that inlet with plenty of all that mulch there, and boom, all of a sudden, you have a floating wetland. I'm not sure if you can get credit for nutrient removal in a floating wetland here for this one, but this was actually an abandoned skimmer. We've actually seen trees growing out of these for skimmers that have been abandoned for a long period of time. And again, these skimmers are they're temporary skimmers meant for the construction phase on a project. And again, this is just showing that the larger skimmers actually we have these slots cut in here, but very easy to just open this up and clean out that orifice. It never gets clogged. So it kind of discussed the maintenance on these skimmers, but it's really good to if you get out to the site, if you have turbid water in the basin, it's probably important to reapply the flocculants as specified. You want to remove and properly dispose of the sediment when it accumulates to half the design volume, or remove trash and other debris from the skimmer, especially against the skimmer, the emergency spillway, and the pool area. And you also want to periodically check the embankment, the emergency spillway, and outlet for erosion damage, piping, settling, seepage, or other concerns around the toe or around the barrel, and repair those immediately. So there are some other skimmer designs out there. These are some pictures of other ones. Some of them are actually homemade. If you ever get on a site and you see this purple stuff, you want to see the purple glue, and housing inspectors want to see this in your house to make sure that the plumber glued your plumbing together before putting up the sheetrock. But we should never see this purple stuff on a skimmer on a project. It means it was homemade, and there's just no telling how or if it will drain. You can see on this one, the orifice is not below the water, so this is not going to drain properly. Again, having the vent above the orifice is not going to prevent siphoning. This is a poor connection here, taking a perforated pipe or a flexible corrugated pipe attaching to the PVC. This is not airtight, so you can see this barrel is full of air floating on top, and you're really just draining from right here at that poor connection. So as I mentioned, there's other skimmers out there, and there are other manufacturers of skimmers. So there are other options out there. And back in 2013, Georgia Soil and Water, before they reissued their erosion sediment control manual, they went to the Texas Research Institute down in Denver Downs in Anderson, South Carolina, and asked them to evaluate these floating surface skimmers. And TRI published this and presented this data at the International Erosion Control Association's annual conference in 2015 in Portland, Oregon. And basically the takeaway, I boiled down the 30-page report to this right here, is that each skimmer product has a unique performance, including the associated hydraulics, which is affected by the flotation, inlet, and drain design chosen. The discharge rate is dependent on the specific product design and can only be determined through product-specific testing. And this is really important. It basically says that not all skimmers drain at the same rate because they use different design components. And that just makes sense. But unfortunately, in North Carolina, we, especially with the DOT, when skimmers are spec'd on those projects, they just say use a 1.5 inch skimmer, a 3-inch skimmer. They just call it out by skimmer size. And as we'll get into, not all of these, and you can tell they don't look the same. They're not made from the same components, and therefore they do not drain at the same rates. So what we're looking at here is these are 2 3-inch skimmers. We're not identifying these by brand, just to highlight this is a type 1 skimmer and a type 3 skimmer. The flow rates are in gallons per minute. When the basin is full at almost 4 feet of depth, this one's draining at 53 gallons per minute. This one's draining at 90 gallons per minute. And as the basin gets lower, here we're looking at when we're getting really low at 7 and 8 inches, we're getting really these things. This one's flowing at 33 gallons per minute. This one's flowing at 66 gallons per minute. And these are both 3-inch skimmers. So if you were to use one skimmer design with it, say you used this type 3 skimmer as your basis for design, and you're anticipating it to flow, at the 66 gallons per minute. Well, if this skimmer was installed in that, it's not going to flow fast enough, so you're probably going to be overtopping your emergency spillway even after a small rain event. Conversely, if this skimmer was used as your basis for design and you installed this one, you're your basin will probably never fill up. You don't get that time for settling, and you're going to be discharging more turbid water. Same thing goes with here's the 6-inch skimmers, and you can see the difference in flow rates on these. This one's 236 gallons per minute. This one's 457 gallons per minute. And to kind of highlight what that looks like, these are the flow rates, the flow characteristics for the different, there's actually three 3-inch skimmers, a type 3, a type 1, and a type 2. There's the 1, 2, and 3. You can see how these flow at dramatically different rates. Same thing for the 6-inch skimmers. So in Georgia, they actually require you to put the manufacturer's name on the plans. And this is, again, they recognize that the flow rates are dependent on the type of skimmer that was used during the design calculation. So they want to know what manufacturer was used as the basis for design. Now so here's how you specify or select and specify a skimmer. The performance, it's really a performance specification based on the volume of water we need to capture and the time, the number of days that we want it to dewater in. There is an ASTM standard for calculating the dewatering time on the skimmers, and it is best if you're a designer to put the name of the skimmer manufacturer on the plans. I know on a lot of public projects, we need to, they don't want a sole source or a proprietary specification. So if you are going to put or approved equal on your plans, you want to make sure that you're getting an equal to what the product that you designed with. The Faircloth skimmer's been out there a long time, and a lot of people use our sizing calculator. Probably 98, 99% of the time that we see plans with a named skimmer on that, it will be a Faircloth skimmer. But we see or approved equal. So you want to make sure if you use our design calculator to design this, that you are, if you're accepting alternative products, you want to make sure that that product has been tested. Again, it's a manufactured product, not a homemade product, and you need to send the dewatering calculations back to the engineer to get them to sign off on it. And I just tell engineers, this is a way to really protect the integrity of your designs. You're not letting a grading excavating contractor undo all those drainage plans and dewatering calculations that you spent all that time calculating. It can be undone at the very last step of your project by allowing an inferior product to be, or an alternative product to be installed. So this is what we like to see on the plans when you call out the required volume, the number of days to dewater, and again, putting the skimmer size and orifice diameter right there on the plans, making it easy for the contractors to see what you're calling out on your plans. And again, there's a very easy calculator to use on the website, and most of the manufacturers will have a sizing calculator. So on this one, you see we just have 68,000 cubic feet of water that we need to capture. We wanted to drain in 3 days, and so this is telling us that we need to use a 5-inch skimmer with a 4.2-inch orifice. I'll just drag in a 5-1 just to kind of show you what that looks like. So say if we want to do 92,000 cubic feet in 2 days, it's going to tell us we need a 6-inch skimmer with a 5.7-inch orifice down here. And if you were to say put in, if we want to do 200,000 cubic feet in 2 days, and you hit enter, now we get an error message saying the maximum flow rate for a single skimmer is exceeded. More than one skimmer may be required. So you might need to use multiple skimmers, but within reason, we want to make sure that we're not putting too many skimmers in a basin. We do have guidance for using multiple skimmers in a basin. This is out in California, a large landfill. Doesn't get a lot of water until they do, and they need to be able to treat it quickly. But again, too many skimmers in a basin can get tangled, and while this is actually just a testing basin, there's valves down here at the bottom of each of these to turn it on and off. But if we use multiple skimmers in a basin, you might need to rethink the, is the basin catching too much kind of runoff from off-site, or probably just need to rethink the drainage areas or the calculations for the skimmers if we end up using too many in a basin. So lastly, we're going to finish talking about post-construction stormwater ponds, and we have an innovative new technology. It's really a flow control technology for controlling, for going in post-construction stormwater ponds. And these permanent stormwater basins really suffer from some of the similar problems that sediment basins do, that they don't always fill and drain properly to give the intended benefit. They drain from the bottom, releasing the most polluted water, and they utilize weirs and orifices that only hit the peak allowable flow rate when the pond is completely full. Outlets easily clog with trash and debris, which adds to operations and maintenance costs. And in general, they do not efficiently utilize that expensive hole in the ground. And so, let's not forwarding here. Let's see. There we go. So in the DEQ, here's the stormwater design manual. Lists the primary and secondary SCMs, and really I put this note up at the top that we're determine the treatment capability, the TSS removal, nutrient removal, volume reduction, and peak flow control required on the stormwater control measure. Determine which SCMs will meet the treatment capability requirements and create a short list, and then we're going to evaluate that short list and see what's most appropriate to use on our projects. And so the latest thing that we've come up with is this permanent stormwater skimmer. It's really an innovative flow control device for post-construction stormwater management. Unlike the temporary sediment basin skimmer, this is made out of a marine grade material here, marine grade plastic, a starboard plastic, Schedule 80 PVC. We're looking at close to a 30 to 40 year expected life on this. And as you can see, this is there's trash guards, trash racks in the back, on the sides, and on the bottom of this. But what makes this really unique is the flow capacity of this. Again, the orifice is near the top, so it provides a constant head and is larger than the construction stormwater or skimmer. So it can actually handle larger flows and is less likely to clog. So we took the skimmer down to Auburn and put it in their tanks down there. They had a digital level logger that took readings every 5 seconds and logged those. And so we were able to come up with this dewatering data. And the interesting thing here is that you can see we're able to hit peak flow rates in these basins at a depth of only about 3.5 feet, which is really important when we compare that to traditional basins that are usually anywhere 6 to 8 feet deep. And there's a paper based on that research that was collected. There was a paper presented at the IACA this past year in Minnesota. Came up with a sizing calculator for this new stormwater skimmer. You can see all the data points that were collected. It was triple replicate data to come up with these flow rates down here. And really what makes this unique is when we look at the different hydrographs, the inflow versus outflow hydrographs. Here's our inflow hydrograph and our hydrograph using a weir orifice. This represents the volume of water stored in the basin, and when utilizing a traditional weirs or orifice, we only hit that maximum allowable peak flow rate when the basin is completely full, when we have the maximum amount of head pressure over that bottom weir or orifice. With this new stormwater skimmer, we're able to hit that flow rate much earlier in the rain event and carry it much longer. And so what this allows us to do is to show a potential reduction in the storage capacity. This kind of highlights again what we just looked at, but this volume underneath this, right in here between these two curves, this represents the potential reduction in the storage for these basins, and it represents about 20 to 50% potential reduction. So we're still working. We're waiting to get our TSS reduction data back from Auburn. We're anticipating it to be at least 20% reduction in TSS. And once we do that, we'll be taking this to DEQ to review for potential inclusion as a SCM for stormwater management. But it's a way that we can easily convert sediment basins to post-construction stormwater ponds, maximize land use with potentially smaller ponds by reducing the volume of impoundment required. And these are great for retrofitting existing stormwater ponds. That's probably the biggest interest we've received from inspectors and regulatory personnel is the potential to get these underperforming ponds working properly. Maybe they are receiving additional runoff from additional impervious surfaces contributing to the runoff, more intense rain events, or maybe just they were just poorly designed or installed ponds to begin with that don't have enough capacity for handling rain events. So, and we're able to do that by we can achieve those peak flow rates earlier and longer than traditional basins with bottom drains or perforated risers. So there's lots of resources. I like to point this out on the website. We can see these at the, you can get cut sheets, design drawings, that sizing, skimmer sizing calculator there right there on the website. We are located right here in Hillsborough, North Carolina. This is our Eno Mountain facility. And again, it's a modern manufacturing and distribution facility right here in North Carolina, where we manufacture a lot of these pieces. We don't really use any off-the-shelf parts other than the PVC that we start with in building these, using, again, these CNC machines to build these pieces and have inventory on hand and typically ship same day or next day. So don't let contractors tell you that they can't get these, particularly if we're in North Carolina. And okay, I just saw one question pop up. What is this? I think we're pretty much at the end, but I will.
Hey, Brian,
Yes,
I have several questions. Do you want me to just start from the beginning?
I see those. I just opened up the chat. I saw one pop up just a minute ago. I minimized the WebEx page, so I will go through these. I'm right here at the end, so then I'll. So this
so
is
sorry. I did not mean to interrupt your presentation. I'm so sorry. I thought you were answering questions. I apologize for that.
I saw it pop up. I thought it was at the end. So this is just a kind of a funny picture that Warren, looking through some of his old slides, we found this, and this was inlet protection. From the good old days, and in the past, sediment control, it just had to be an effort, not necessarily good or successful, just an effort. And today with inspections and testing of discharge and public awareness, sediment control has to be successful. And so we just like to point out that using a faircloth skimmer in sediment basins is just one component of achieving that success. And so I am here at the end, and we still have few minutes here. And listed. Okay. There is a question regarding PAM, and there is a maybe someone from the DEQ. I know I've been to it. I can't tell you exactly what page, but there is a list for flocculants, and it might be under flocculants instead of PAM. Rebecca asked the question, where the PAM list is on the NCDEQ's GWR website. Or actually, I think she's just posting that for everybody.
Yeah, she was just letting everybody know that that's where, yeah.
Yes, okay, that's great. I just clicked on that. Okay, good.
I can read the questions out to you if you want.
What's that?
I said I can read the questions out to you if you
Sure,
want. Okay.
yeah.
All right. So the first one was from Bill. He wants to know, are these percentages based on volume or mass? And so that was probably around 1126. So he wanted to know that. And I think that's probably back at the beginning of your presentations, because I'm not for sure what percentages he's talking about.
The percent, I'm sorry, what, could you repeat the question, Michelle?
He said, are these percentages based on volume or mass? So I'm assuming he's.
That was based on Melanie's research, and that was on, that's a very good question. I believe that was based on mass, because they were measuring the actual volume of sediment that was captured in the basins.
Okay. All right. So the next one from Andrew said, if the volume of a basin is to be cleaned out at half capacity, how does a semi-full basin influence the efficiency of baffle walls? I.e., if baffle walls are 1/2 full of sediment, then will they work well enough to disperse the water energy?
They will, because the volume that is reduced will be on the bottom of the basin, so the baffles will still be controlling that flow at the top of the basin where the water is flowing through. So it will, they will still work, but like anything, you know, with that diminishing capacity, it will reduce the efficacy of those baffles, because, you know, half the baffles are buried under sediment and will not be able to slow that velocity or that volume down and disperse that energy.
Okay. All right. The next one for Francine saying, are you finding that contractors are actually using these skimmers? And if so, what compels them to use the skimmers?
Yes, they so in North Carolina, they are very common practice, pretty much in the southeast. So the construction general permit requirement of utilizing an outlet structure that withdraws water from the surface, that is what really compels them. And North Carolina, both DOT and the DEQ's ENS handbook or manual requires the use of surface drains. So that's what really drives their usage. There's certain states that have non-numeric turbidity limits, particularly on the West Coast. I'm sorry, where they have numeric turbidity limits, like hitting an NTU of 25 in Washington State. That alone, that's typically where we get into active treatment. But throughout the Southeast, the Carolinas, Georgia, Alabama, Tennessee, Ohio, Pennsylvania, Mississippi, those states are, they utilize these to a very high degree.
Okay. All right. The next question, are you finding that many contractors are able to reuse skimmers on multiple projects by replacing the orifice as needed for common sizes like a 2-inch or a 3-inch skimmer?
That's a good question, and yes, they can. And typically, again, that comes down to buying a quality skimmer. Some of the there are a couple other skimmer providers out there that use they use screws to screw in the screen over the orifice, and those screws they are very hard to get out. Will typically strip, and the type of screw that they use with the in conjunction with the aluminum screen tends to create an oxidate that kind of fuses it in place. But we see a number of contractors reusing these, particularly folks that have used them over the years. Oftentimes these go in on the front end of a project by a grading excavating contractor who is long gone when that project is, or when that basin, that temporary sediment basin or trap is filled in. So they're not always there to kind of harvest them off of it. But for some of the general contractors that install their own basins, we do see them collecting these and carrying them on to other sites. We do sell replacement plugs and plates for those orifices. So if you need to put a restrictor size, or if you call out a 3-inch, say a 3-inch skimmer with a 2.75-inch orifice, and you need to get that orifice plug, we actually we sell replacement parts for that, and the flex hose. Sometimes when they remove these, they just cut the flex hose to remove these, and so we have contractors that will purchase replacement flex hoses or the orifice plugs or plates.
Okay. Tyson, I think your question was answered already. Is the stormwater skimmer approved in North Carolina? He made a statement that it could be a game changer in the mountains. So, so Brian, I mean,
not approved yet. So we're just this is new technology. We've done all the testing. We're still waiting on Auburn to get us back our TSS reduction. So we need to take it to DEQ and get them to approve it as a stormwater control measure. But that's the next step.
Okay. All right. And so the next question, wouldn't the stormwater skimmer exacerbate the potential for downstream flooding by allowing stormwater to leave the basin sooner or earlier? Also, the basin's purpose is to retain that water, not to necessarily process it quickly.
And that's a good point, Tom. That's a really good point. There is a and I should have pointed that out. So there is we're designed to a peak flow rate. So we won't exceed that peak flow rate of what was permitted. And in some states, like Alabama, they have a water quantity rule. And so it's all based on water quantity, moving water off the site as fast as possible. Some states have more of a water quality requirement. Some states have both. So this is intended to really address both of those. We will not be discharging water faster than the maximum allowable peak flow rate, but we design it to that max flow rate or that peak allowable flow rate, and we just achieve that sooner in a rain event than a traditional basin with a bottom weir orifice where you have to fill up the basin completely to get that maximum amount of head pressure over that bottom weir or orifice to achieve that peak flow rate. So hopefully that answers the question.
Okay. All right. So Jeff wants to know if the presentation will be available for viewing. Brian, do you mind sharing that with me so we can post it on our website?
I don't mind at all. And,
okay.
And my information is on here too. So if anybody wants to reach out to me directly, I can send a Dropbox link or something like that. But yes, I will share it with you, Michelle.
Okay, perfect. And I'll post, of course, that, and the recording for today will be on our website, per normal, per usual. I think this is the last, maybe one or two more questions. James wanted to know, is there a good resource for used skimmers that I can direct more cash-strapped property owners?
Okay, I'm sorry. Yes, please, if you could. Thank you.
Okay. He wanted to know if there was a good resource for used skimmers that he can direct for property owners that are more cash strapped.
Not that I'm aware of. I haven't seen any on eBay, but I don't. There's the skimmer. The smaller size one, the 1.5 that we typically use, like in a sediment trap. I mean, you're looking at a cost of about $400 for the little one. So I mean, when they get into the large ones, the 8-inch skimmers, those are you're pushing about $5,000 for those. But in the overall cost of construction, these are really just kind of a drop in the bucket compared to the overall cost.
Okay. Dan wants to know, do you have a specific written guidance on disassembling faircloth skimmers from outlet structures after construction project is completed and stabilized, and for the conversion of the basin into a permanent post-construction SCM?
No, not that it has, but I see that one. This is one fair house how it's structured.
Okay. All right.
So these are actually, they're typically glued on, and what a lot of customers will do, there's set screws on there, so you take the set screw off. A lot of times what they will do is they will just typically cut it and cap it with a PVC cap that would just be glued over top of that bottom kind of outlet where the skimmer is attached. It would just typically cut it off and glue a PVC cap over top of that.
Okay, I think this is the last question. I have to look and see. Robert wants to know, will having longer peak flows cause an increase in strain erosion?
And those are all things that we're that we'll be reviewing with the DEQ. Ideally, you're going to be treating the same amount of water. Again, we would be discharging it at a higher rate for longer, but this is all based off of that maximum allowable, that peak flow rate. So we won't be exceeding that peak flow rate, but potentially that could be an issue that we'll have to look at.
Okay. All right, and actually, this is the last question, Brian. Sorry for keeping you guys longer, but I just felt like if you needed to jump off, of course, you could. So James wants to know the graphic that mentions baffles in the particle size settling. Has anyone looked into using a combination of core or sediment fencing, especially using said fencing at the most downstream outlet adjacent baffle?
Well, sediment fence, if you recall, the way the sediment fence baffles were installed is they were cutting notches out of that. So it's really like Virginia and I don't know if Virginia they use plywood baffles, which is obviously a solid baffle, and that's essentially what we're looking at with the sediment fence is creating it would be a solid baffle, and when they used those, they found that it concentrated the flow and kept the velocities up. So I'm not sure. I have not seen research utilizing the combination of the two, but I guess there is a possibility that you could use it. I'm not sure that there would be any benefit to using a solid baffle like a sediment fence at the very end.
Okay. All right, and Brian, that concludes all the questions that we actually had for today. And I just wanted to thank you again for taking time out of your schedule for assisting us with this webinar. And we've gotten a lot of comments that they really enjoyed it. So thank you again. And want you guys to let you know that to tune in for next month's webinar. It's November the 16th, and Melanie McCabe will be from NTU Inc. will be talking about turbidity. So what I'll do is I'll drop the link again if you haven't already gotten the link for the PDH credit. So I'll put that in here again right now, and so just complete that evaluation, and I will get that to you guys as soon as possible. And if there's not any more questions, Brian, do you have any more comments or anything that you want to make before we conclude the webinar?
I don't, but Melanie McCaleb is the one whose research that I cited in there from NC State. So some of these questions in regards to that research, she's the one who did it. So she will be a good person to answer some of those questions. But thank you for having me.
Oh, well, thank you so very much. And I'll stay on for a few more minutes in case somebody didn't get the link. But hey, thank you guys again for joining the webinar. Like I said, this wouldn't be a success without you. So thank you so much, and you guys have a wonderful rest of the day. Thank you again, Brian.
Thank you.